Hello there and welcome to the second session. This is called Sensor Diagnostic Data as the Key to Condition Monitoring. I'm joined here with Adrian Francos and Benedikt Jörg, both product managers. I said they were excited. They look excited about these products, and there is something to be excited about. So it was a little bit of a joke, but now it's going to be quite earnest. What I want to say before these guys start is please write your questions into the chat. We will get to them, like I mentioned. That really helps us see if there's people interacting with us. We really like that. So I'm going to let them take it away. Adrian, I guess you're speaking first.
Thank you, Patrick.
Yeah, see you.
As strategic product managers for cylinder sensors, respectively new business fields, we are maintaining a close collaboration in order to make your life easier. Therefore, we will show you today how we already offer sensor diagnostic data as key to condition monitoring. To make this big topic, diagnostic data in connection with condition monitoring, tangible, we use our MPS-G position sensor for small cylinders and grippers as an example.
So you might have seen this picture already in the previous session. Max focused on the upper part. He focused on condition monitoring use cases by refining existing data. This session will focus on the bottom layer in this picture, so the data acquisition. We will show you on the example of the MPS-G how sensor data enables condition monitoring by its sensor performance, by the actuator diagnosis data, and the process diagnosis data. But first of all, what is the MPS-G about? Could you please describe the sensor in a few words and maybe also demonstrate it?
Sure, Benedikt. This small guy is our MPS-G. M stands for magnetic, P for position, S for sensor, and G for gripper. It's a small pneumatic, it's a small magnetic position sensor for miniature grippers and cylinders. We have a very short sensor head with 25 millimeters, and we are able to serve all commonly used C-slots. The separate teach unit is for the configuration of the switching points, respectively the measuring range. Main applications are the monitoring of gripping process and the end position detection on small cylinders. MPS-G offers in general three innovative functionalities. The dynamic teach, that means that the sensor is able to set the switching points automatically due to the application. The second one is the actuator diagnosis functionality. Here, MPS-G measures data like the field strength and count cycles and so on. And last but not least, the process diagnosis functionality. Here, MPS-G gathers data like temperature, vibration, acceleration, and the temperature. We would like to show you quickly the functionality in a short live demonstration. So now we should switch to my screen. Perfect. As you can see here, the process data is transmitted in millimeters from 25 millimeters to plus 25 millimeters. In the general device settings, the taught values can be reset. On the next page, you can set the switching points via the dynamic teach or manually. And the hysteresis of each switching points can be adapted as well. Now we are coming to the diagnosis functionality. As you can see here, we're having the actuator travel, the cycle time, the dwell time, start position, the cycle count, and so on. And the process diagnosis functionality is divided into 3 pages. Here we're starting with the temperature and the acceleration, the orientation of the sensor head, and the vibration behavior. And now we would like to focus on how to do condition monitoring with these functionalities. But first of all, we would like to explain what condition monitoring is about. Perfect. Apparently, all of a sudden and without any warning, a plant component fails due to wear and tear, causing an unplanned machine downtime. Condition monitoring as a maintenance strategy represents the approach these failures announce themselves in advance. The warnings and signals must be recognized in time. And therefore, the condition of a machine is monitored at regular intervals or even permanently by measuring certain machine and process values. That means in the first step, we collect the data, and in the second step, we analyze the data in order to avoid such sudden machine downtimes. But Benedict, can you please get more specific and tell us which problems can be really solved?
Sure. Condition monitoring minimizes the following 6 problems: high maintenance costs, short machine lifetime, a short machine availability, unexpected failures, a fluctuating production quality, and various variants on one machine. But we would not only like to talk about the theory. To get this more specific, we have an exemplary application with us. So in this application, we measure the width of workpieces during a gripping process. Therefore, the MPS-G is mounted on a pneumatic gripper. So the challenges that need to be solved by condition monitoring are there are various variants on one machine processed by actually one machine and the gripper. The production quality can fluctuate due to wrongly gripped workpieces. A leakage can lead to unexpected failures. Unplanned downtimes due to underperforming components in the actuator can lead to a short machine availability. And unauthorized machine adjustments can also lead to a short machine lifetime. Unplanned service interventions will, of course, cause high maintenance costs. So these are the problems we are dealing with in this application. So how can we solve this with the MPS-G?
Yeah, let's have a look how to solve this exemplary application with MPS-G. In assembly line, 3 part variants which differ in width can be processed. And the goal is to differentiate these 3 part variants during the gripping process. Therefore, MPS-G measures the stroke, respectively the position of the gripper fingers, and transmit this position value via I/O link.
So, as you have seen, by measuring the exact position of the gripping fingers, we are able to process several variants on one machine. But what about the others?
As already mentioned, MPS-G measures the actuator travel, the cycle times, the dwell times, the current field strength, and so on. And with the actuator diagnosis data, it is possible to see what inside the actuator happens during the operation. And so conclusions can be drawn regarding the entire machine process. This picture shows the actuator diagnosis dashboard as already seen during our live session. Let us give you now 4 examples. The detection of leakages, the prediction when a cylinder will fail, the identification of underperforming components, and the detection of unauthorized machine adjustments. Let's start with the first possible behavior. First possible behavior could be that the piston moves slower and the stroke gets shorter. And a possible conclusion could be, due to a leakage, not enough compressed air gets into the actuator. The second example, an exemplary predefined lifespan of a cylinder could be 2 million cycles and 120,000 meter actuator travel. And a possible measure could be to replace the cylinder before the predefined values are reached. The next possible behavior, could be that the stroke gets longer. And a possible conclusion which could be drawn, the shock absorbers are damaged. And last but not least, when all values suddenly change, a possible conclusion could be that somewhere in the machine an adjustment with negative impact has been made. So Benedict, which problems are solved right now?
By evaluating the actuator diagnosis data, we are able to enhance the production quality, to minimize the unexpected failures, and to extend the machine availability. So we get a lot of information out of the sensor, but it is still not enough to handle all the challenges we have within this application. So therefore, we have the additional process data, and we can get more information out of our application. The MPS-G delivers information about vibration, shock, orientation, and temperature. So let's start with the first one, the vibration. The sensor processes the raw signal into key values. These key values help to interpret changes inside the actuator. But please be aware that the success depends on the knowledge of your failures. Otherwise, you know that you have a deviation, but you do not know the cause, why there is a deviation within these vibration values. The next information about is the shock. So downtimes or malfunctions result from unforeseen shock during the assembly process. Therefore, the MPS-G monitors the maximum acceleration detections and therefore can display shocks and monitor the condition. The orientation information is very useful for movements and dynamic applications. So in our application, the MPS-G monitors the orientation of the gripper and can therefore give this information to the upper periphery. If the gripper shows wear, friction as well as vibration can occur. This friction can lead to a heat generation. So in our application, the gripper can get a high temperature and therefore can be an indicator of failure. So by evaluating all the process diagnosis data, we are able to extend the machine lifetime, to avoid high maintenance costs, and therefore solve all the challenges we have within this complex application. And all challenges are already solved. Of course, a periphery is still needed which prepares and processes and also visualizes the data. But as you have seen by Max, we also provide the solution. But the MPS-G lays the foundation for condition monitoring.
Let us shortly summarize our session in a few words. We, as SICK, offer sensor solutions with outstanding performance. The combination of the actuator diagnosis and the process diagnosis enables you to solve well-known problems in production by monitoring the condition. Thank you.
Yeah, thank you very much. Now I know why you guys are so excited about cylinder switches. It's pretty amazing. I think what I took away from it before I get to the chat was that, yes, you can detect whether it's there or not there or what position it is, but on top of this you have values, so the analog values, and on top of that, then at that position you get quality information about the run health of the machine. So yes, you can use it for, we're not going to complain, again, if you just are using it as a normal, simple sensor, but there's so much from that position that you can get to increase the availability of the machine. So now I understand why these guys are excited. We also have a couple questions here. And here's a good one. What's the frequency range in hertz? For this question, I have to maybe see if we can clear this up. Is this probably the switching frequency that we're talking about? Do you guys know switching frequencies that it can reach?
We can
actually slides. We are prepared. We are well prepared. As you can see here, the data. If we are talking about switching frequency, let me see. I don't have it in my mind right now. Do you see the switching frequency?
You got a bigger screen over there.
Perfect. Yes. The switching frequency about. So it's not in the.
It looks like there's the orientation. We have an update rate.
Yeah.
What we can also do is send it in the chat if we.
Yeah, perfect.
Can't
Let's
find
send it in the chat.
Yeah?
Yes.
We'll send it in the chat. That was a good question. So even keep the tough questions up. This is live. We also enjoy it. There is an answer to this question, so we'll send it to you in the chat afterwards. There's another one. Are there more sensors equipped with diagnosis functionality? Say you're not super excited about cylinder switches. Are there other sensors? Yeah?
It's also a very good question. Of course, we see the potential and also the trend for digitalization and added values out of one sensor. So up to now, we have a magnetic line guidance sensor, which is also equipped with vibration, shock detection, and orientation, which can be very useful for HEV guidance and all that stuff. But of course, we see in the future that it's very beneficial if we equip the existing sensors with MEMS elements, which deliver information about vibration, orientation, and shock. So you get more transparency out of your application.
And we're probably not going to have every sensor that we make with a MEMS chip because there's certain positions in the process where it makes sense to glean that information from the process. So this goes back to what we were talking about in the beginning. You can transform everything and it costs quite a lot of money, but you do it in positions that make sense. So that really came through in this presentation. So yeah, thank you very much. Again, we'll get back in the chat to get that answer. What's the frequency? I think there was a good REM song. If you guys remember it, you can type in the chat if you remember. No? We'll get back to that one.
And we should be specific with the frequency because it's a position sensor and there's not a switching frequency, but it has to be clear what kind of frequency is asked for.
We need some more information from you. So you've been challenged in the chat to give us that information. Thank you very much to both of you. Please stay with us. We're going to go in a little bit to the next session, which is bringing data to life with augmented reality. This is another one that I teased in the very beginning. It's super exciting. Please stick around for the next session. And thank you very much. Thank you, guys.
Thank you.
Yep.